DeepSeek just built an AI that thinks step by step like a human, and it's running on a fraction of the computing power everyone said was impossible. And that's why the entire AI industry is quietly freaking out right now. So here's the thing. For the last couple of years, the story we've been told is that bigger always wins. More data, more compute, more money equals smarter AI. OpenAI, Google, Meta, they've all been throwing massive resources at the problem, assuming that raw scale is the only path forward. But DeepSeek, a Chinese AI lab that most people outside the industry have never heard of, just proved that assumption wrong. And they did it in a way that has implications way bigger than just one company. Let me break down what reasoning actually is in AI terms, because this is where it gets interesting. Most of the AI you interact with every day, ChatGPT, Claude, even Gemini, they work by predicting the next word. You ask a question, they calculate probabilities for what word should come next, then the next one, and so on. It's fast, it's smooth, it feels natural. But here's the catch. They can't really show their work. They can't say, okay, step 1, I'm breaking this problem down. Step 2, I'm checking if that makes sense. They just output an answer. Reasoning, on the other hand, is different. It's when an AI actually walks through a problem methodically. Think of it like the difference between someone blurting out an answer versus someone sitting down with a notepad and actually working through the math. The AI thinks out loud, essentially. It shows you the steps. And crucially, it can catch its own mistakes along the way. OpenAI's O1 model was the first big public example of this. Released last year, it blew people away because it could solve complex math problems, write better code, reason about tricky logic puzzles. But it had a massive downside. It was slow. Like, really slow. It had to think through everything step by step, which meant latency was brutal. And it required enormous amounts of compute to train. The assumption was that reasoning models would always be like that, a luxury for when you have time and money to burn. Then DeepSeek dropped their reasoning model, and they basically said, what if we're smarter about how we train this? What if instead of just brute forcing it with more compute, we actually design the training process differently? Here's where it gets technical, but I'll keep it simple. DeepSeek used something called reinforcement learning, which is not new, but they applied it in a really clever way. Basically, during training, they let the model generate long chains of reasoning, those step-by-step thoughts, and then they only rewarded it when the final answer was correct. Not when the steps looked perfect, not when the reasoning was eloquent, just when it got the right answer. This sounds simple, but it's powerful because it forces the model to figure out what actually matters for solving the problem, rather than learning to mimic human-like reasoning. They also did something called process reward modeling. Instead of just looking at the final output, they trained a separate model to evaluate whether each step in the reasoning chain was actually useful. This is like having a coach who watches your work and says, that step was good, that one was unnecessary, that one was wrong. The model learns to be more efficient, to cut out the fluff, to focus on what actually moves the needle. The result? A reasoning engine that's actually faster than you'd expect, runs on less hardware than the industry thought was possible, and performs at a level competitive with OpenAI's O1, all with a fraction of the resources. Now, why does this terrify people? Let me count the reasons. First, it breaks the narrative that only the richest labs with the most compute can build frontier AI. If DeepSeek can do this efficiently, so can other labs. So can smaller companies. The moat around AI leadership just got thinner. Second, it suggests that the next big breakthrough in AI might not be about throwing more money at the problem. It might be about being smarter algorithmically, which means the race isn't necessarily won by whoever has the biggest budget. Third, and this is the part that really matters geopolitically, DeepSeek is based in China. And the fact that a Chinese lab is now at the frontier of AI reasoning, using techniques that are harder to restrict through export controls because they're about clever training rather than specialized hardware, that changes the whole game board. But here's what I think is the actually important part, the thing nobody's talking about enough. This is evidence that we don't fully understand how to build smarter AI yet. We're still discovering new approaches. We're still finding inefficiencies. That means the path forward is not predetermined. It's not just scale up forever. It's about insight, about finding the right architecture, the right training process, the right incentives. And that's both exciting and a little bit humbling, because it means the experts don't have all the answers. For you, Practically speaking, what this means is that reasoning models, the ones that actually think through problems, are probably going to become more accessible faster than anyone expected. You might not need to wait for OpenAI to release the next version of O1 at a premium price point. Competitors are going to push on this, and competition drives down cost and speeds up deployment. The other thing it means is that the AI race is less about resources and more about ideas, which is a good reminder that we should be paying attention to what's actually happening in labs, not just the hype cycle. Because breakthroughs come from unexpected places, and they often come from people asking, what if we did this differently, instead of what if we did this more? If you want to actually keep up with moments like this, the real technical breakthroughs that reshape the industry before they hit the mainstream, subscribe. I break down one of these every few days, and honestly, it's the only way to not get blindsided by what's actually happening in AI.